Assalamualaikum friends and doctor. We are from group 7. Today we are going to discuss about the and definite integral of calculus. First, we are going to introduce ourselves. My name is Anas Walapus Sorparata. My number matrix is 204726.
Hello and hi, my name is Muhammad Fawaz bin Azhar and my metric number 196190.
Hello, my name is Baimu Han. My control number is 201690.
Next. So what is an indefinite integral? So a function of f is called an indefinite of a function f in the interval I if f derivative x equal to fx. The original function fx is called the integral of f derivative x. Then fx dx equal to fx plus c, where f derivative x equal to fx, and c is an arbitrary constant. In this notation, this one is the as we can see, there's the integral sign. Fx is the integrand, dx is the differential of x, which denotes the variable of integration. C is called the constant of integration. Next, some rules of integration. First, there is a constant rule, and then power rule, log rule, and then exponent rule, sum and difference rule. We can see all fives here. Next, examples. First, we have 3x to the power of 2 dx. So the solution is 3x to the power of 2 dx equal to 3. We take out the 3, and then x to the power of 2 dx, and then make it as 3 x to the power of 3 per 3 plus c equal to x to the power of 3 plus c. Oh, by the way, we are using can you previous the slide? We are using the power rule. Next, and then number 2, there is a integrand of 5x plus 7 dx. So the solution is 5x dx plus 7 dx. So we take out the 5, and then x dx plus 7 dx, and then 5 1 per 2 x to the power of 2 plus c plus 7x plus c2, and then equal to 5 over 2 x to the power of 2 plus 7x plus c. Next, integration by substitution. Examples, 1 over 1 minus 2x dx. So how to solve? Let u be equal to 1 minus 2x. So du over dx equal to minus 2, and dx is minus 2 dx. So 1 over 2 and then minus 1 and per 2 du equal to minus 1 per 2. Then take the 1 per u du, and then substitute the 1 minus 2x for u and minus 2 dx for dx. So this is the result, minus 1 over 2 ln u plus c equal to minus 1 over 2 ln, and then 1 minus 2x plus c. Next, integration by part. We have x to the power 2 e to the power x dx. Okay, so we are going to use this product rule. The integration by part state then when fx g derivative x dx, we are going to use the rule where fx gx minus gx f derivative x dx. So here we can see let fx be equal to x to the power of 2, f derivative x equal to 2x dx, and then gx equal to e to the power x, and then g derivative x equal to e to the power f dx. So x to the power of 2 e to the power f dx equal to x to the power of 2 e to the power x minus integrand e to the power x times 2x dx equal to x to the power of 2 e to the power x minus 2 integrand x e to the power x dx plus c. And then set f equal to x and du equal to dx. So here x e to the power x dx equal to x e to the power x minus integrand e to the power x minus 1, time 1 and time 1 dx. So it will be integrand x to the power of 2 e to the power x dx equal x to the power of 2 e to the power x minus 2x, minus 2 x e to the power x minus e to the power x plus c. And this is the result, e to the power x to the power 2 minus 2x plus 2 plus c. Next, economic application of integral. So we have, suppose a publishing company has found that the marginal cost at level of production of X thousand magazines is given by C derivative X equal to 25 over root of X. And then that the fixed cost, the cost before the first book can be produced is 36,000, and then find the cost function. So this is how to solve. Integrand of 25 over root of X dx equal to 25x minus to the power of minus over 2, because the sign of the root is minus 1 over 2 dx, and then equal to 25 2x to the power of 1 over 2 plus k, and then become a 50x to the power of 1 over 2 plus k. So find the value of k, and then you use the fact that C0 is 36,000. So Cx equal to 5x to the power of 1 over 2 plus k. So 36,000 equal to 50 times 0 plus k, then k equal to 36,000. So Cx, so the cost function become Cx equal to 50x to the power of 1 over 2 plus 36,000.
Okay. Hello and hi. So we will continue our topic with the finite integral. So the finite integral will divide into two. The first one proper integral, and the next one is improper integral. So for the first one, that is the definite integral equation. A as the lower limit and b is upper limit. This is integral fx dx equal to limit. So this one is the integral. And then the second one, the fundamental theorem of calculus. So A equal to integral A lower limit, B upper limit, fx dx. So we will divide the integration. This is the properties of the finite integral, right? So there is five. The first one is sum or different, and then constant, multiple, reverse interval, zero length interval, and adding interval. So this is the basic one, the foundation of the integral. All right. So next, the previous slide is about the theory and the foundation. So let's go to the application. So the first one, application, area under the curve. So the question is finding the area of a region under the curve. What is the area between the curve y equal x square minus 4 and the x-axis? So as we know, this is the figure y equal to x square minus 4. So the limit for x-axis is negative 2 until 2, and the in y-axis is negative 4. So the solution, the region is depicted in the figure. So how to solve this question is, this is the limit, the lower limit negative 2, the upper limit 2. So we put the equation x square minus 4 dx. So the first one, we have to integrate the equation. So x, the power of 3 over 3 minus 4x, and put the limit, the lower limit negative 2 and the upper limit 2 equal to 8 over 3 minus 8 minus with the second one we put the lower limit negative 8 over 3 plus 8. So the answer is 16 over 3 minus 16, and the final answer is negative 10.67. Okay, we have to note from the figure, this figure, the area is negative because it is below the x-axis. Okay, so if we look to the shaded region, this is negative because it's below x-axis. Right, this is the first one. And the second one, the application is area between the curves. So the question is finding the area of a region between two curves. If R is the region bounded above by the graph of the function fx equal to x plus 4 and below by the graph of the function gx, gx 3 minus x over 2 over the 1, 4, find the area of region R. Okay, we can see the shaded area. The in x-axis, the limit is 1 until 4. Okay, so the solution, the region is depicted in the figure. So the formula is as always, the limit AB fx minus gx dx. So the first one, we put the lower limit 1 as the figure, x-axis 1, and the upper limit 4 as the figure 4. And then x plus 4 minus 3 minus x over 2 dx. Okay, so we solve the equation limit 1 4 3x over 2 plus 1 dx. So we solve the question. After we solve the question, we integrate it. So 3x square over 4 plus x, the limit 1 4. So the next step, we substitute the x with the upper limit 4. So it's 16, and then minus with, we substitute x with 1, 7 over 4. So the answer is 57 over 4. So the final answer is 57 over 4 unit square. So this is basically the improper integral. So the first one is proper integral, so and the second one is improper integral. Let's now formalize up the method for dealing with infinite interval. Okay, so the difference between this improper and proper is this one, the lower limit is a and the upper limit is infinity. And then this one is the lower limit is negative infinity and the upper limit is b. So that's how it works. We will substitute the limit with infinity and negative infinity. Okay, let's look to the example. All right. So finding an area. Determine whether the area between the graph of fx equal to 1 over x and the x-axis over the interval 1 positive infinity is finite or infinite. So we can look into this figure. So this is the term. So so limit, this limit t positive infinity integral 1 and upper limit t 1 over x dx. So we integrate this one ln x and then the limit is 1 t, and then after we separate it, limit t goes to positive infinity ln t minus ln 1. So we change the t, we substitute the t with the positive infinity. So the final answer is positive infinity. So note, since the improper integral diverge to positive infinity, the area of the region is infinite. All right. So continue with Menghan.
Okay, we can continue. Cosm and product supplies. Cosm supplies is concluded using CS equal ln QE0 dq minus P QE, where CS is the Cosm supplies, dq is the demand cover, P is the equilibrium price, and QE is the equilibrium quantity. Product supplies is concluted using PS equal PQE minus ln QE0 SQ DQ, where PS is the products and supplies, SQ is a supply and cover, P is the equilibrium price, and QE is the equilibrium quality. Next. A plantation using equilibrium quality and the price to find the consumer and the price supplies. So exam find the equilibrium quality and the price and the concept and the price supply. DQ equal negative 0.25Q plus 30. SQ equal 0.05 cross append minus 2. In order to find the equilibrium quality, we need to remember that our system will achieve equilibrium when supply equals demand. In other words, if we set the supply cover equal to the demand cover, the residual Q value will be the equilibrium quality QE. So we can say negative 0.25Q plus 30 equal 0.05 Q supply minus 2. So we can source of Q equal 15. Since the equilibrium quality must be positive, QE equal 50. So next. Equilibrium quality for the given demand and the supply covers. So we can say DQ equal SQ equal. So we can supply SQ equal 0.05 Q5 minus 2 is P equal 9.25. Next. To solve for custom supplies, we will plug the demand cover plus the equilibrium price and the quality into the custom supplies formula. So CS equal along 50 minus 0.25Q plus 13 DQ minus non-curve 25 plus 15. So we survived CS equal 18 for car 13.75. The consumer supplies is this 18 for car 13.75. So next. Now we can solve for the prices supplies by pricing the supply cover and the equilibrium price and the quality into the process supplies in question. PS equal 9.25 15 minus long 15.00,5 Q5 minus 2 DQ. So we can subvent PS equal 111.1375. So the precision supplies is 111.1375. Last example, magical cost and benefit calculation. The exam is the result fashion of selling Q enters of the country products is IQ equal. It 100 Q minus Q, and the server's Q over 4. The conclusion magic Raven function. Magic Raven when serves for them is 200 enders. This is simple, so we can survive the honors Q equal 800 minus Q over 2. 2 honor 200 equal 800 minus 200 over 2. So the survivor answer is 700. Okay, my part is finished.
Thank you so much for your attention, doctor and friends.